Hello, Mr. Ruth here. Today we're getting away from the cognitive stuff and we're going to do some kind of old school notes. I have posted this assignment in these notes in Google Classroom in PDF if you want to print them out and follow along. I'm also going to post the completed notes as well, so if you want to just refer to those once we're done. But this will feel a little more like old school in the classroom back before all this Corona stuff hit. All right, so let's get started. We're talking about vectors, and today we're going to talk about a new way to express vectors. So far, we've been expressing vectors in component form, and we've been primarily using two kinds of notation. We've been saying something like, all right, vector v is equal to, let's say, 4, 3. Or we might be saying vector v equals 4i plus 3j. Both of those are two different ways to express the same vector. This has, this vector goes 4 in the x direction and 3 in the y direction, and that's why we call it 4 over 3. Now, if you complete this, what shape do you get? Well, you get a rectangle. So sometimes this form of vectors is called rectangular form. All right. In rectangular form, both of the components are distances or lengths. All right, so that's rectangular form. That's the form we've been using. Today we're going to talk about a new kind of vector form called polar form. So polar form does not use two lengths. Instead, polar form uses a magnitude. So one of them is a distance or length, but it also expresses the vector with an angle. The direction is expressed as an angle where one of the sides is the positive x-axis. So this angle expresses a direction, and the angle it expresses is the positive x-axis. So let's see what I mean by that. So if we had the same vector we were talking about before, like so, instead of calling this vector 4 over 3, I might say, all right, what's the actual length of this vector? Here it might be 5. And then I'd say, and what's the angle of the vector from the positive x-axis? What is this angle? Not sure exactly what it would be in this situation, but maybe let's say, 33 degrees. And so in polar form, I might express this vector as 5, 33 degrees. Or I might say the magnitude is 5 and the angle theta is 33 degrees. All right, so that's polar form. Couple quick examples. Here you're asked to sketch a vector with a magnitude of 7 and a reference angle, or a theta, of 45 degrees. So I'll start with the angle. Remember, this works just like trigonometry used to work. Okay, positive x-axis is 0. I get to 90 here, 180, 270, all the way back around is 360. So 45 degrees is going to be something like this, and the length is 7. So this is the vector. Over here, I'm sketching a vector with it's a unit vector. It has a length of 1 and a reference angle of 210. So again, I kind of go around. There's 180. A little bit past that is 210. There's my vector, and it's got a length of 1, so I write the 1 right there. Okay. Answer a few questions and click on to the next video.